Our kids. All right, now our next installment in the Switch video series. I have a parallel circuit, okay, with an amp meter here, an amp meter here, a voltmeter there, and a voltmeter there, okay, and my switch right here. So the question is going to be, when you close the switch, what's going to happen to this reading, this reading, this reading, this reading, and why? Okay, so let's make sure that makes sense. If you want to, like at the start, if we let's actually compare the stuff at the start. So let's do this right now. Compare this to this, okay, and compare this to this with the switch open. Okay, so if you want to pause it and talk about that, and then I'm going to talk about it. So with the switch open, so we'll do open with red, open. Okay. With it open, let's trace the current, because again, let's trace the current. So the current comes out, goes through here, gets to here, and it splits. Now it splits two ways. It's going to go this way, and then it comes back together and goes here. So if you take a look, assuming they all have the same resistance, okay, if I assume that, it will split equally. That means this is 1/2 of this. Okay, so when it's open, A1 equals 2 times A2. Okay, so like whatever this value is, this is going to be 2 times it. Okay, hopefully that makes sense. Current is going to split up. And then with it open, if you take a look, so with voltage, I'm going to connect my fingers. Okay, hey look, it's connected here. Do you see how, oh, that's connected there. Oh yeah. Oh yeah, look, this is all the same point. Oh, that means V1 and V2 are going to be the same. So V1 will equal V2. Okay, hopefully that makes sense. Okay, when you close it, I will do closed in blue. So again, if we trace it out, okay, so if I trace it out, current comes out. Now when I close that switch, it splits 3 ways, and then it comes back together. Okay, so if it splits 3 ways and then it comes back together, well that means, okay, that the total resistance of my circuit, okay, my total resistance of the circuit is going to decrease. Why? Because there's one more path to go around. When you add resistors in parallel, the total resistance goes down, which means my total current is going to go up, which means A1 is going to go up. And then, okay, what's going to happen to A2? Well, this one, you're going to actually have to do a little bit of math. So let's do a little bit of math. We don't have to do a lot of math, but we do have to do a little bit. So if you're ever not really sure, like, what's going to happen, make up easy numbers. Okay, so what's an easy number for us to work with? Let's say at the start, let's say this is 1 ohm, 1 ohm, 1 ohm. This is 1 volt, okay? At the start, that means I would have 1 amp flowing through here. I would have 1 amp flowing through here, and I would have 2 amps flowing there. Is everybody with me there? Okay. Okay. Well, and that makes sense with what I said here. If I close that switch, that means I would also have 1 amp flowing up there, which means that this would be now 3 amps. Do we follow that okay? So, oh, well, what's going to happen to everything? Well, this went from 2 amps to 3 amps, okay? And you can solve for that stuff. But you'll notice this stays at 1 amp. Why does it stay at 1 amp? Well, the reason it stays at 1 amp, the voltage didn't change, the current or the resistance didn't change, so the current is still 1 amp. So A2, when I close the switch, A2 stays the same. A2 stays the same. A1 increases. It went from, a little bit more. Went from 2 to 3, and then V1 and V2 still equal each other. Hopefully That makes sense? Bye, kids.